Today we're going to look at our notes on page 5 of our chapter 8 packet, page 5. And what we're going to talk about today is something called a common log. There's some vocabulary on this page that I'm not going to hold you responsible for, but I just wanted to introduce you to some of the terms that you might hear. And we're also going to talk about the product rule and the quotient rule and the power rule a little bit more. We were introduced to that in the last video. First of all, a common log. Well, way back in the late 1500s, early 1600s, when logarithms were invented over in Europe, the mathematicians there set up logarithms. They're large logarithm tables, and they used the base 10 because the base 10 is the base of our number system. And so when they were computing logarithms, they always used base 10, and that's because human beings have 10 fingers. And that's why we have a base 10, but that's why the common logarithm, the earliest one developed, was base 10. And that's just a little bit of a history lesson for you. Now, when the base is 10 on a logarithm, the base doesn't need to be written as the subscript of the word log. And so how I'm showing you that is in these examples. In this first example, it says the log of 1 equals. Well, you're going to look at this and say, well, I don't know what the base is. It's not written. Well, if the base is not written, it's assumed to be base 10, so I'd always like you to write a little 10 in there if you don't see the base written, because it's just assumed. And this expression says 10 to the what power is equal to 1? Well, it doesn't matter what the base is. 10 to the 0 power is equal to 1. In other words, 10 to the 0 equals 1. So the log of 1 is 0. Well, what's the log of 10? Well, we're going to insert our little 10 here because when it's not written, we do. And we're going to say 10 to the what power equals 10? 10 to the first. And over here, we're going to insert a little 10. 10 to the what power is 100? Well, 10 squared is 100. And last, inserting a little 10 because it's not written. 10 to the what power equals 1,000? 10 cubed. The next vocabulary word, anti-logarithm, it looks a little scary. I'm not going to hold you responsible for this vocabulary word, but all it is, anti-logarithm is actually the number that's going to 10 to the whatever power is going to be the anti-logarithm. That's how I'm going to explain it. So if you see an equation like this, log of x equals 3. Well, you're not going to do the log of 3 because they don't want you to do the log of 3. X is the anti-logarithm. The anti-logarithm is the inverse of the logarithm. So what this is really saying is you're going to insert a little 10 because it's not written. And this really means 10 to the third power is equal to x. Well, 10 to the third power is 1,000, so x is 1,000. X is the anti-logarithm in this problem. So if you're ever going to find the anti-log, all you have to do is say, if you see an equation like this, all you have to do is say, oh, I'm going to insert my little 10, and 10 to this power is equal to x. Well, I don't know 10 to the 0.3456. So now we need to grab a calculator. So you're either going to use a scientific calculator, or you're going to use a graphing calculator. And if you hit the buttons second log, it's going to automatically show you, it's going to raise 10 to the power of whatever. I'll show you on the graphing calculator also, it's the same thing. You're going to say second log. And then that just gives you a base 10, and in this example, 0.3456. So that answer is 2.216. I think I'll just round it to it doesn't tell me how many decimal points to round it. Oh, I guess I'll just write it all out. 2.216154.326. Hopefully you have either a graphing calculator with you or some kind of a scientific calculator or some kind of an online calculator that you can raise 10 to the power of 0.3456. And you get the same answer. Find the anti-log of negative 0.2345. So I'm going to insert a little 10 because this is a common log. The base is not written. And so I'm just going to hit my second log button, which is 10 to the power of negative 0.2, and that looks like it is 0.58277377748. And that's all an anti-log is just 10 to the power of whatever that number is on the other side of the equal sign. So that's it for an anti-log. But you should be able to calculate x if I give it to you in this way numerically. And you have to have a calculator of some kind in order to do this. Down in the bottom of this page, or the second part of this page, I'm just going to review with you the product rule, quotient rule, and power rule that we learned in the last video. And hopefully you remember just from yesterday that the log of a times b is actually the log of a plus the log of b. One log splits into two logs. This one log splits into two logs, log of a minus log b. Notice I wrote the word log 2 times. And then if you have an exponent, you're going to circle this exponent, drop it way down front, and this is going to become x times the log of a. And those are the 3 rules that you need to know for logs. They're not that complicated, hopefully. Let's see if I can focus this a little bit better. Okay. So in this part of the paper, this is telling you that we're going to make some substitutions. Whenever we see the log of 2, we're going to substitute that with an a. Whenever we see a log of 3, we're going to substitute that with a b. And the log of 10, we already found out the log of 10 is 1 up here. So this is a log of 10. Now these bases, because they're not written, they're all base 10. But it really doesn't matter because these whole exercises 1 through 8 are all base 10. This instruction says write the expression in terms of a and b. So we're going to be replacing log 2, log 3 with a's and b's. What that means to us is we're going to take this argument here, this argument of 6, and we're going to have to rewrite 6 in terms of 2's and 3's using multiplication or division or a power in order to rewrite these terms. And this is how we would do it. Well, 6 is actually equal to 2 times 3. So in place of a 6, I'm going to write the word log again, but 6 turns into 2 times 3. And remember, the log of AB is the log of A plus the log of B, so this one log splits into 2 logs. The first one is the log of 2, and then added to that is the log of 3. And then the last step is anytime we see a log of 2, we're going to replace it with the letter A. Anytime we see the log of 3, we're going to replace it with the letter B. So this answer would be A plus B, and that is the end of that problem. In the end, you should not have the word log in your final answer. You should only have A's, B's, or 1's. Number 2, our argument is 4. Well, how can we create 4's out of 2's or 3's? Well, there are a couple ways. We're going to rewrite the word log, and 4 can either be written as 2 times 2, or you can rewrite 4 as 2 to the 2nd power. Either one, you're going to get the same answer in the end. So we're going to use the product rule that says log of 2 times 2 is the log of 2 plus the log of 2. The log of 2 is equal to A, the log of 2 is equal to A, and A plus A is 2A, and that's the end of the problem. Or if you'd rather write it this way, you can use the power rule and bring that exponent down to the front, and this becomes 2 times the log of 2. Well, the log of 2 comes out and gets replaced with the letter A, so the answer is 2A. It's the same answer, it's just 2 different ways to do it, and it doesn't matter which way you like, whichever way you want to do it. Now here's a 20. Now we have to create a 20 out of 2's, 3's, or 10's. Well, 3 doesn't go into 20, but 2 and 10 do. So we're going to rewrite this as the log. 20 turns into 2 times 10, just like 6 turned into 2 times 3. We're going to use the product rule that says this is the log of 2 plus the log of 10. And the log of 2 gets replaced with an a, and the log of 10 gets replaced with a 1. A plus 1 would be our final answer. The next one, how do we create 60 out of a 2, 3, and a 10? Well, probably a few different ways, but the way I can think of is 2 times 3, which is 6, times 10, which is 60. So 60 turns into 2 times 3 times 10. So now we have 3 factors, so we're going to break it up into 3 logs. This is the log of 2, plus the log of 3, plus the log of 10. Log of 2 is a, log of 3 is b, log of 10 is 1. A plus b plus 1. Notice there's no log in my final answer, just a's, b's, and 1's. Number 5, this is just a quotient rule. We don't have to rewrite it. All we have to do is call this the log of 2 minus the log of 3. That's the quotient rule. Log of 2 is a, log of 3 is b. A minus b would be our answer. Log of 6 over 10. Well, 6 turns into 2 times 3. So this is actually the log of 2 times 3 over 10. So we have a quotient rule. Remember from yesterday we used the quotient rule first. So this is the log of 2 times 3 minus the log of 10. Says the quotient rule. Now we have a product rule. The log of 2 times 3 is the log of 2 plus the log of 3 minus the log of 10. Log of 2 is a, log of 3 is b, log of 10 is 1. A plus b minus 1 would be that final answer. Now anytime you want to, we have a couple more on this page, so if you'd like to try these last couple on your own, I would encourage you to just shut the video off right now and try these last couple on your own if you can. And then turn them on, and you can turn the video back on again, and then you can hear how you would solve these last 2 problems. So what we have, 30, is changed to 3 times 10 all over 2. So now we have 3's, 2's, and 10's. The quotient rule is first. This is the log of 3 times 10 minus the log of 2. The log of 3 times 10 is the log of 3 plus the log of 10 minus the log of 2. And our last step is to replace the log of 3 with a b, log of 10 with a 1, and the log of 2 is a. So b plus 1 minus a would be the final answer here. And 9 can be written either as 3 times 3 or 3 squared. It doesn't matter. I think I'll rewrite 9 as 3 squared. I think it makes it a little tiny bit easier. 3 squared over 20 is 2 times 10. So that's how you would rewrite that argument. The quotient rule gets used first, so this is the log of 3 squared minus the log of 2 times 10. Log of 3 squared, you're going to bring that 2 out in the front, says the power rule, and this is 2 times the log of 3 minus, now I need parentheses because I have a sum here. This is the log of 2 plus the log of 10, and this negative gets distributed through this parentheses. So the log of 3 is b, so this turns out to be 2b minus the log of 2 is a. Now this negative goes over here, so it's minus 1. Be very careful of distributing that negative throughout both those terms. On this side, we're not going to complete the whole page 6. We're just going to go up until question number 8 down here. We already mentioned natural logs yesterday or the day before. A natural log is just a log that has a base e. And remember what e is. It's that irrational number. You can find it either on a graphing calculator by hitting second divided by. There's e. That's the number e. Or if you have one of these scientific calculators, you can, let's clear this up, you can hit second ln. That's e to the power of 1. So e to the power of 1 on the scientific calculator also will show you that answer. Whenever you see an ln, I would encourage you to write it as log base E every time. It just makes things a little bit easier when we're trying to rewrite things in exponential form from log form. For example, on number 1, it says solve to 3 decimal places. Well, actually, what this becomes is this is just a button on the graphing calculator, and the button is this ln button here. So x equals the ln of 88, and all it is a calculator question, and the ln of 88 is that long number, and it says solved for 3 decimal places. So you look at the 4th, 3 keeps the 7 a 7, so to 3 decimal places that would be 4.477. And it's the same thing on these calculators, just hit the ln of 88 and you get the same answer. Over here, we're just going to subtract 1 from each side, so x is equal to the natural log of 200, parentheses, minus 1. So in the calculator, we're just going to do the natural log of 200, close up the parentheses, and subtract 1 from that. Be sure you close up the parentheses or you're not going to get the right answer. So this is 4.298 if you round it to 3 decimal places correctly. Number 3, you're going to add 1 to both sides, so the ln of 44 plus 1 is equal to 2x. And then you divide both sides by 2 to get x. Let's see, I'll use this calculator. Now you need to have parentheses because you have more than one term in the numerator. So you have the ln of 44, close the parentheses, plus 1, plus 1, close the parentheses, and then divide that whole thing by 2. And there's your x value, 2.392. And number 4, you're going to subtract 2 from each side, and you get 3x equals the natural log of 500, close parentheses, minus 2, and then divide both sides by 3. So we're going to just do the parentheses, the natural log of 500, close parentheses, minus 2, close the parentheses, divided by 3. So 1.405, it looks like this 8 is going to be rounding the 4 up to a 5. So we've got 1.405 as our final answer here. Hopefully you saw everything that I was writing. And then the last 4 problems for today. These are exponential equations. And if you notice, the x is in the exponent on all of these cases. And whenever you're solving for the exponent, you're going to use logs. We're going to rewrite as a log equation. This is really important if you're trying to solve something like this. So I would rewrite this. I would say to myself, x is the exponent, which is a logarithm, on little base e, that's going to give me an 88. Well, the log base e is the same thing as the ln of 88. And we've already done the ln of 88 up above, so I'm not going to put it in my calculator again. I already know it's 4.477. On number 6, x is going to give me, or is equal to, or is the exponent on base e that's going to give me a 200. Oops. Well, log base e is ln, so this is actually the ln of 200, and I've already done the ln of 200 minus 1. Oh, I guess I'll just do the ln of 200. It's pretty easy. So the ln of 200 is 5.298. The next one, e to the 2x is 2,000. So 2x is the exponent on my little base e that's going to give me 2,000. Or in other words, the ln of 2,000. So if I divide both sides by 2 and change log base e to ln, I've got the ln of 2,000 divided by 2. So the ln of 2,000, close the parentheses, divided by 2, oops, is 3.800. And the last one for the day, x minus 5 is the exponent on my little base E that's going to give me 3,200. Well, I'm going to add 5 to both sides to solve for x. So I'm just going to tack on a plus 5 over here. And x is equal to, log base E is ln, the ln of 3,200 plus 5. So the ln of 3,200, close parentheses, plus 5 is 13.07, well, the 9 rounds the 0 up to a 1, so 13.071. And that's it for today. We'll get practice on this tomorrow in class.